My name is John Williams, and I work at Colorado State University, and I'm the director of the Center for Electric Propulsion and Plasma Engineering. My role on the SPAR project is to develop an Ascent-compatible cathode. So these cathodes that we're going to be using on this next generation of thrusters that Ben's involved in developing are going to be running on alternative propellants. And the particular challenging thing about Ascent is that it has water, a lot of water in it, and some CO2 and other things, and those things contain oxygen, of course, and the oxygen tends to destroy conventional cathodes, damage them so that they can't work, and we're trying to come up with a cathode that can run on those devices. And then, what would that enable? There's some really cool things that it would enable, and you guys may already know this, but if we can get the cathode to run on Ascent with the thruster, Ben will have demonstrated the highest power level ever demonstrated on a Hall thruster, the highest thrust level, and the highest thruster efficiency. It would be the first ever demonstration of running on Ascent for a Hall thruster system, entirely on Ascent. And then the other super cool thing about this whole project, which people don't talk about that much, is that we're hoping to be able to turn it on for kind of a very short time and then leave it off for a short time or a longer time, so that we can have it on at different duties. So you can go from being totally off to being totally on continuously. And that allows you to throttle, what we call throttling a thruster. And that throttling capability has never been demonstrated before, 0 to 100%. And that would all be at the highest performance point, which other people have throttled, but not over that kind of a range, but they don't get the same performance when they throttle power down. And so anyway, it would be a trifecta and historical event, and then really would be great for the University of Michigan and for the team. Most of my career has been involved in developing cathodes for various applications, ground-based plasma processing, and then through electric propulsion and something called plasma contactors. It's neutralizing spacecraft charging events on orbit. So our focus at my lab is on cathode development. Some of our major objectives, and in this program we've been referring to them as key performance parameters. And so we want to be able to hit in this first phase 300 amp operation. We want to be able to turn on the cathode very rapidly, get it to an operational state within 1/10 of a second, so that we don't have much impact on the system in trying to get it on and off, because that can hurt performance. And then we want to be able to operate at different duty cycles to do that throttling that we talked about. Kind of the last thing is we're taking a cathode and we're coupling it to a Hall thruster, and Hall thruster is producing thrust, producing ions that are emitted to space. And our job is to provide electrons that neutralize this ion beam. And the amount of voltage that you need to couple the electrons from the plasma electron source into the beam is one of the measures of performance, and we want to keep that voltage as low as possible. Ideally around the 30 volt range, but definitely below 60 volts would allow the performance of the system to be world class. So what we're going to be doing over the next year, we have two kind of main tasks, and we split them up into subtasks just like you do in any engineering project. But one of them is to further develop these cathodes and put them in what's called a standalone configuration, standalone test configuration. It means that you put a cathode in an environment that simulates what it would look like in a thruster, and then we go through all our testing, like we talked about, starting tests and different duty cycle operation, different currents and flow rates. We do that all at our lab at Colorado State University. And then the second task in the overall project is to bring these cathodes, we'll send a few throughout the year, but we're going to bring these cathodes to the University of Michigan, integrate them with their thruster, and then assist the thruster team in getting their thruster performance that they're hoping to get. So our work would benefit the Space Force by enabling, so we're just one component, but it turns out it's a critical component, and it will enable the Hall thruster system to work and to be used by the Space Force to move assets around in orbit. And the Space Force You know, they have satellite assets and they have power generation capability on orbit. But they, you know, it's right now it's the lower power level. And they eventually in the future will build to higher power levels. Part of this institute's goal is to get nuclear reactors in space on satellites. But right now we have other ways of generating power and it's limited. And this particular system that we're talking about, we can store up a little bit of power and run it through the power processor and run the thruster for a short time at its max power point. And then we could just sit around and wait as the system recharges for the next impulse that we do. And so what's really cool about the overall project is that the Space Force could potentially utilize the technology right away, even though they might not have enough power on orbit to use it fully. And then as their assets grow in orbit and their capabilities grow, they'll be able to use the same thruster without having to develop a whole new propulsion system every time they have a new satellite, because that's what we currently do right now. We develop small thrusters for small satellites and medium thrusters for medium satellites and then big thrusters for big satellites. It would be the same thruster system, same propellant management system, same power supply system, and then it's just put on differently sized Space Force assets as they grow. So we can, you know, it's a new agency. There's all kinds of interesting things that we could do, moving assets around in orbit with this technology. Everything between, you know, the low Earth orbit all the way out to the moon's orbit, and you know, basically helping them do their job, kind of protecting the U.S. and the world.